Hey guys, back to a new video. This video is about stacks and queues. This video is powered by Codercite, our channel. Okay, so first of all, what are stacks and queues? Stacks and queues are basically abstract data types. But what is an abstract data type? Okay, you have a data type called as data structure called as list, right? List in Python, array in other languages, even array in Python also. So how do you represent a list? You represent a list by two braces and you're gonna put elements into that. Okay, let's put 1, 2, 3 like that. This is a list, right? But what's with abstract data type? Abstract data type is the data structure by itself which you create yourself with using the inbuilt data structures, that is an ADT. So how do you implement stacks and queues using the list in Python? Okay, so this is the basic structure of a stack and queue I have written over there, and the operations also I have written over here. What are the operations you could perform on stacks as well as queues? Okay, first of all, let me tell you what a stack is. Stack works on a principle known as last in first out, that is LIFO. It basically works on last in first out, that is the last element which is pushed onto the stack is the first element to get out of the stack. Seems interesting, right? The last element to get into the stack is the first element to get out of the stack. But what's the case with queue? In queue follows a technique called as FIFO, that is first in first out. What is first in first out? The first element to be pushed onto the queue is the first element which is gonna be popped out of the queue. So where you can see the implementation of the queue? You can see implementation of queue in real life when you're standing in a queue to buy your tickets for your cinema. That's a queue, right? The first person to get into the queue will get the first ticket. That's how queue works. First in first out, and stack is opposite, last in first out. Okay, now let me do some operations over stacks and queues and explain you how it works. Okay, basically stack and queues are data structures which looks something like this. It's a list by itself, but implementation is beyond list. That's what I can tell. Okay, this push operation in the stack will be the same as the append operation in the list. So take a list, let me write here, take a list A, let it be empty for now, and if you append element 1 to A, the list A will look something like this. That's right, if you append an element, that element gets added to the list A. It's also the same in case of stack. If you use push in the stack, it is same as appending an element onto the list. Okay, now I will push element 2 onto the stack. Element 2 is pushed. Now I will perform push 3. Push 3 is nothing but append 3. Okay, I have appended 3. Now I will perform push 4, it's same. Append 4. Now it comes to pop. What is pop? You know about removing the elements from the list, right? If you want to remove an element from a stack, you need to perform the pop operation. Even if you want to remove the element from list also, you need to perform pop, but you know, it's sometimes called as the terms in computer science. Okay, what happens when you perform that pop operation? This pop operation basically removes the last element which was pushed onto the stack. Okay, so what was the last element that was pushed onto the stack? 4, right? So pop operation doesn't take any parameters itself. As push operation did, push operation took the data which is to be pushed onto the stack. but pop operation doesn't take any data in it. Okay, the pop operation itself will pop the last element which was pushed onto the stack outside. Okay, and one more thing, when I do this pop operation, the last element was 4, right? This will get popped out of the stack. And it's not just the case, the pop statement will also return that value to the console. So if you perform this operation on a Python console, if you pop an element from the list, you will get that element as output. That's what I meant. The pop statement will also return that value. It's not only just gonna remove that value, it's also gonna display the value which was popped from the list, which was popped from the stack. Okay, now 4 is not more in the stack. Let me just erase the 4. Now, this size operation. What is the size of a list? What is the size of the stack? The size of stack is nothing but size of list, right? What is the size of the list? The length of the list, right? That's what. The size operation just returns the length of the list. I'll show you the coding implementation in Python in my next video about how to code a stack and how to code a queue. But in this theory lecture, I'm going to explain all the theory concepts. Okay, this size will return the length of the stack, that is the length of this list. Let me call this a stack A. Okay, the length of the list is 2, the length of the stack is 2, so this will return 2, this returned 4, this returned 2, that is the length of the stack. Okay, what is isEmpty? isEmpty is a function, isEmpty is a method which you implement by yourself. It will return a boolean value, either true or false. It will return whether the length of the stack is 0 or not, that is, if there are elements present in the stack or not. So what's the operation of that isEmpty? isEmpty nothing but returns length of stack equal to 0. So what is length of stack equal to 0? It is false, right? So it returns false. What if stack had no elements in it? Like both 3 and 2 were not there in the stack. Now length of A is equal to 0 will return true. So the isEmpty method is gonna return true. That means it suggests that the stack is empty and there are no more elements in the stack. So this was about stack. I'll explain you the applications of the stack in this video itself. Just hang on. Now let me just come to queue. Okay, this is the same operation which I'm gonna perform on queue was the same operations which I performed on stack, but it's somewhat different compared to stack. So I'll just push 2. Here in queue, push is not append actually. It is an insert statement. An insert statement takes 2 parameters. The first is the position in the array or the position in the list where that element has to be pushed, has to be appended, and the element itself. Okay, push 2 is nothing but, let me take this as B. Let me take this queue name as B, and when you perform push 2 operation on the queue, that is B, it's nothing but B dot insert. I already told you, insert takes 2 positional arguments. One is the position in the list. Obviously, if you want to perform first in first out, you should not stack one over the other. You should stack one below the other. That is nothing but inserting the element at the 0th position. Insert at 0 and take this element. Okay, let me just write ELE. This is a general syntax or the general command when you perform push operation on a queue. Okay, So now let me push element 2. As there are no elements in the stack, the first element to be get into the queue is 2. Okay. Now let me push 3. What happens if you push 3? When you execute this command, the command comes over here. B is the name of the queue. Dot insert at 0th position what element 3. So what will happen is this 2 will get pushed over to the position 1. This is position 1, this is position 0. Get pushed over to position 1 and then 3 gets here. That's what the queue does. Okay, now let me push 4. Again the same thing happens. Instead of writing those there, I'll just write 4 over here. And index 0, index 1 and index 2. You got that, right, how a queue works? But what does the pop operation in a queue do? Okay, when you pop an element from the queue, even here pop doesn't take any kind of parameters or arguments, position or arguments in it. But what it does is, it will return the first element which was pushed onto the queue. What was the first element pushed onto the queue? 2, right? Yeah, it's what the first element that was pushed onto the queue. So after performing the pop operation, it is the first element which will get out of the queue. So there is no more 2. 2 is not there in the queue right now because I have popped it out of the queue. Okay, now size. Even size here returns the length of the queue, that is length of the list B, that is 2, as there are 2 elements in the queue, and is empty is also same as the stack, which will return whether the queue is empty or not. That's what a stack and queue is. Now coming to comparison, what's the time complexity of inserting an element in a queue as well as a stack? In stack you can append an element or else you can push the element in O of one time, cause if you append 1, you can append 2, you can append 3, you can append 4, like that. It is amortized value cause the list itself doesn't have infinite amount of memory. You know about amortized arrays, right? If you don't know, I'll just explain you just a bit here. Okay, in C and C++, you know something about dynamic memory allocation, right? Like if you have an array A, you need to pre-specify the size of the array before you apply any kind of push or pop operation on that, or insert or delete operation on that. You need to pre-specify the size of the array. But in Python, you need not pre-specify the size of the array. And it doesn't mean that the array has infinite memory. What happens here is, the array is dynamically implemented. The list is dynamically implemented by default in Python. What happens? This concept is known as amortized arrays. Okay? So initially the list, when you call A equal to null list, what it happens is, it will allow 0 space in it. Okay, when you append an element A dot append 1, A becomes 1, right? Now the memory it is holding is not just one element, it has memory left for another element also. So it is like multiplying the length of the list by 2 if the size gets overloaded. Okay, now if we just append 1, what it creates is it creates a memory block of size 1 times 2. This 1 is not the element, this is the number of times the append operation is happening. It's not the element. I can even push 10 and still the memory size will be 2. I mean 2 blocks will be assigned and this will be 10 and the next memory block will be a junk value. We don't know what will be the value of that, but it will be still reserved. What if you append 20. This becomes 10 comma 20. Now this size of the list is exhausted. What happens if you append 30 onto the list again? If you append 30 onto the list will become 10, 20, 30, right? You might see this as an easy operation, but what is happening internally over there is, as soon as you implement this command, the size of the list is doubled, cause the size of the list is exhausted over here. Now the size of the list is doubled, that is 2 times 2, that is 4. After it exhausts 4 elements, it becomes 4 times 2, which is equal to 8. After it exhausts the size of 8 elements, it becomes 8 times 2, that is 16. So it can handle 16 elements in it. If it exhausts 16 elements, it can handle 32 elements. Like, it will just dynamically improve the memory size. It will just dynamically increment the memory size. That's what amortized array means. It's not dynamically implemented manually, but it is dynamically implemented automatically. Even you can do this manually, but no need of doing it manually, right? When you have an automatic operation. Okay, now coming to the applications of stacks and queues. What's the application of stack? You all have coded in editors, right? Code editors, Visual Studio, like that, Turbo C, all those. All those things have autocomplete brackets, right? Like, if you type a.append, and if you open a single bracket, it will automatically close the bracket for you, right? That's what it do a parenthesis balancing. The term is parenthesis balancing. The parenthesis is these are the parentheses. It will do the parenthesis balancing. I'll show you in the coding part of the video how to do a parenthesis balancing. It will be a whole new video and not the same video as this implementation of stacks and queues. That is one application of stack. And what's the application of queue? You might have studied LRU cache, right? Least recently used cache in OS concepts. If you don't know about LRU cache, just go through some Wikipedia pages. Do learn about LRU cache implementation, because I can't explain you. It will take around 10 to 15 more minutes to explain what a cache is, what a LRU cache is. That's why I'll just leave it as an assignment. So LRU cache. Is an application of queue. So that was all about this video. I'll show you the Python coding implementation of the same in the next video. Thank you.